Welcome back, architects. Today, we're not just running through another tutorial. No, we're on a quest. Our mission is to cut through that shifting fog of the future, to really master the art of uncertainty, and to turn raw, unpredictable chance into a map you can actually read. This is our journey into the valley of probability.
And this, right here, this is the core idea for everything we're about to do. We are not here to make one single guess and just hope for the best. We're here to become architects, the kind of people who see the entire landscape of what could be. We're going to learn how to map that whole sprawling cloud of possibilities so we understand every potential path, not just the one down the middle. So, the problem we're all up against is that shifting fog, right? The world is just inherently unpredictable. Well, our solution, the tool that's going to let us see through it, is the Monte Carlo Simulation. I want you to think of it like the ultimate map-making kit for the future. And today, we are going to build that map, together, piece by piece. Our journey starts here, in what I call the mirror forest. Now, imagine a place where there's no pre-drawn map, no neat little probability tables to guide you. All you have are these raw, scattered fragments of the past. So our first test, our first challenge, is to learn how to listen to these historical echoes and actually use them to figure out where we're going. You know, here in the forest, we find ourselves at a fork in the road. Two completely different ways to think about history. Over on the left, you've got the Discrete Historian. This approach is super strict. It only trusts what's written in the history books, word for word. It says we can only use events that actually happened. Then, on the right, you've got the Continuous Creator. This path is, well, it's more creative. It respects the past, for sure, but it also believes there's a story between the lines. It allows for things that could have happened, even if they never did. So the tool for the historian is the small function working together with RANDBETWEEN. The logic is actually really simple and elegant. RANDBETWEEN just randomly picks a rank, like say the fifth smallest value, and then small goes and grabs that exact data point from your history. So if your sales log only has shoe sizes 8, 9, and 10, this method will only ever give you an 8, a 9, or a 10. It makes sure our simulation is built with authentic historical bricks. Nothing new is created. Okay, but now this is where things get really interesting. The creator's tool is the percentile function, and it's a total shift in thinking. Instead of picking a specific historical rank, it picks a random percentile, maybe the 37.5 percentile. Then it finds the value that would exist at that point. So if your historical data show delivery times of 10 minutes and then 20 minutes, this method could totally generate a simulated time of, say, 14.3 minutes. It creates a much more fluid, realistic world by building new paths between the old ones. So how does it actually create these new realities? It's all happening because of this beautiful piece of logic right here. Now, don't let the formula intimidate you. Let's just see it for what it is, a glowing bridge between what we know. The left side is basically asking a question. Okay, my random number landed. How far along is it on the path between percentile 1 and percentile 2? The right side then gives the answer. Got it. Now I'm going to create a new value by traveling the exact same proportional distance between your two real data points. This is the mathematical soul of the creator. It honors the past while building a brand new, continuous reality. All right, so we've learned to listen to the echoes of the past. Now, we leave that messy, organic mirror forest behind, and we ascend to the temple of pure logic. Up here, we don't need to sift through old data anymore. In this place, the world is governed by elegant, universal mathematical laws that literally describe the shape of probability itself. In the temple, we get a totally new kind of power. We use these things called inverse functions. And I want you to think of them like powerful spells or incantations. We give it a random probability, our good old RAND function, and the incantation summons the precise outcome that corresponds to it. See the difference? We're not just observing anymore, we are commanding reality. Our first and honestly most common incantation is NORM.INV. This is the spell that commands the normal distribution. You know it, the classic bell curve. It's the signature shape for any process that clusters around an average. Think about machine-filled soda cans, or heights of people, or even test scores. You just tell it the mean, the standard deviation, and give it a random number, and poof. It returns a perfectly realistic value that fits that curve. Next up, we learn the incantation that controls rhythm. This formula, negative mean times the natural log of RAND. It summons a value from the exponential distribution. And this one isn't about the events themselves. It's all about the time between them. How long until the next customer walks in the door? When's the next support call gonna hit the queue? This incantation sets the very pulse, the beat of our operational simulations. And finally, we have the binomial guard. This is a discrete incantation for those clear-cut yes or no situations. You give it a set number of trials, like say you're inspecting a batch of 100 widgets, and a known probability of success, or in this case, a defect. Binom.INV will then tell you exactly how many successes or defective items you should expect to find in that batch. It stands guard on the boundary between success and failure. And here it is, the architect's spellbook. This table is your go-to reference. When you're facing a problem, you just have to identify the shape of the uncertainty you're dealing with. Is it a bell curve? Is it the time between arrivals? Then you just look it up and choose the right incantation from your book. This is how we use pure logic to command the future. Okay, before we can face our final challenge, there is one more fundamental force we have to master. It's the one thing that underpins every single operational simulation we will ever build. And that is the architecture of time itself. We have to learn to see time not like a human, but like a machine. To control time, you have to speak its language. And in Excel, time is just a number. It's called a serial value. Every day is a whole number, just counting up from a starting point back in 1900. And every moment within that day, it's just a decimal, a fraction of 24 hours. So noon is simply 0.5. 6 p.m. is 0.75. To build simulations that actually work, we have to build them using these numbers, not with text that just looks like a time. But a word of warning, inside this beautiful clockwork lies a hidden trap, a ghost in the machine. I call it the temporal rune. See, the Windows 1900 date system has a bug. It thinks February 29, 1900 was a real day, but it wasn't. 1900 wasn't a leap year. If any of your time math happens to cross this non-existent day, your whole simulation could be thrown off by a full 24 hours. A true architect has to know about this ghost to avoid its curse. So here are the essential tools you need to handle time perfectly. To show a duration that's longer than a day, like a 30-hour wait time, you have to put brackets around the hour format, brackets H. If you don't, Excel's clock just resets every 24 hours and all you'll see is the remainder. And please, always build your dates and times using the date and time functions. This guarantees you're working with pure numbers and you'll avoid those fatal text string errors. And now, this is it, the culmination of our entire journey. We've got our knowledge of historical echoes from the forest, we have the logical incantations from the temple, and we've mastered the clockwork of the world. Now we arrive at our final confrontation, the siege of the Great Vault at XDB Bank. We are going to tame its chaotic queue. So here's the puzzle we have to solve. It's not just one line, one server. This bank has multiple tellers. So when a new customer walks in, they don't just go to the end of a single line. They go to the first available teller. The entire simulation hinges on one question. How in the world do we calculate that exact moment? Okay. The logic breaks down into a few steps. First, we just ask, is there an open server? If the number of people already in the bank is less than the number of tellers, great, easy. The customer walks right up and their service begins the moment they arrive. But if all the servers are busy, they have to wait. And that leads us to the final, critical piece of the puzzle. How do we find the precise time that the first of those many tellers is going to be free? And here it is, the secret key, the one function that tames this whole multi-server mess, is large. And the logic it's just so cool and counterintuitive. Let's say you have 3 tellers. You look at the list of when all the current customers will be finished. Now, instead of looking for the smallest time, you ask for the third largest end time. And that third largest time is, by definition, the earliest one. It's the exact moment the very first of those 3 tellers becomes free. And that is when our waiting customer gets to start. This one little function just unlocks the entire problem. It's pretty genius, right? We've done it. The queue is tamed. The vault is understood. Our long journey through the valley is finally complete. But let's take a moment and look back. Not at a bunch of formulas, but at the incredible new landscape that we can now see. You came here seeing the future as just a single path, a single best guess. You are leaving with a map of the entire valley. Your model doesn't give you one answer anymore. It gives you thousands. And every single time you press that F9 key, a whole new, possible future unfolds right in front of your eyes. You can see the best case, the worst case, and all the thousands of different paths in between. You have actually mapped the cloud of possibilities.
So I'm going to leave you with this one question. In your own work, in the decisions you make every day, are you going to keep planning for that single average future and just cross your fingers? Or are you now going to pick up your tools, embrace your role as the architect, and be the one who builds the light that pierces the fog? The choice now is yours.